Now the topic is the vector control, methods of implementations and indices. So you know very well there are many vector-borne diseases that are prevalent commonly in India. You know that malaria, filariasis, Japanese encephalitis, dengue fever, and chikungunya. These are all mosquito-borne diseases. We have Kalas are also sandfly-borne diseases. Other than that, we have Ayasnur forest disease. It is a hard tick-borne disease, and plague also we have. So these are the common vector-borne diseases. So what is important here? Under the program, national program, we are undertaking control measures, vector control measures against mainly malaria. Mainly malaria. Earlier we had been taking larval control measures against Ulus fungifaciatus, that is filariasis vector. Now, in addition to that, against dengue vector, Aedes aegypti and albopictus also we are undertaking the control. So, what is the definition of the vector control? Vector control is any method used to limit or eradicate the vector population that transmits the disease pathogen. What is the ultimate objective of the vector control? It is the reduction of morbidity and mortality. Morbidity and mortality by reducing the levels of transmission. So the question is why vector control is important. Suppose somebody is suffering from malaria or some other ailment, they can go for taking treatment. Why vector control is important? Because the vector control is important in places where the control of vector-borne diseases for which no drugs or vaccine available. You know that dengue, there is no successful vaccine. Even for malaria also. Now they recently they introduced, that is it did not come to India, but only 30% efficacy they have. So the control of vector-borne diseases for which no drugs or vaccine available, interruption of the transmission in areas with the drug resistance, where drug resistant malaria is there, that you can use vector control. Particularly, you can use this during the disease outbreak or epidemics. During the outbreaks or epidemics, vector control is very, very important. Then, moreover, to prevent the epidemics or reintroduction of the malaria or other vector-borne diseases. In areas of vector-borne diseases, particularly the malaria endemic area with high rates of mortality and morbidity, these vector control measures are very important. So, what are the vector control options available for us? One is personal protection measures. Under that, we have that repellent that is used by individuals. Then we have insecticide treated mosquito net, that is ITMN. Then we have long lasting insecticide nets. The second option is chemical control. Under the chemical control only, you have the indoor residual spraying, spray spraying, chemical larviciding. Then you might be knowing that biological control agents, that larvivorous fishes, then BTA, that biolarvicides are also used. In addition to that, you have the in dengue control, mainly we rely on source reduction activities. You remember that source reduction activities that comes under environmental management. Let us see chemical control methods. What are the methods available? Before that, you see that range of classes of insecticide. It starts from petroleum oil, that is malaria oil, organochlorines, you have DDT, SCH, etc., organophosphate. This malathion and temifos comes under that. Carbamates, we have pyrethroids, detamethrin, pyrethrum extract. Then insect growth regulators. We have several insect growth regulators, methoprin, pyriproxine, etc. Biolarvicide, commonly used biolarvicide is BTA. Coming to that, under that chemical control, the main thing is the indoor residual spraying. Where to use the indoor residual spraying? You cannot do everywhere. So you should have large number of structures with adequate sprayable surfaces. Moreover, you should know the bionomics of the vector. The vector should be endophilic. That means it should rest indoor. Suppose it is not endophilic, at least you should come for feeding indoor. That is endophagy. Vector should be susceptible to the insecticide what you are selecting. So ultimately, with the indoor residual spraying, what is the outcome you are expecting? So the indoor residual spray, it will reduce the vector longevity. That means lifespan. Then vector density also it will reduce. Then number of infective bites. Okay, you are clear now, audience? Hello, participants. Hello.
Hello,
Yes,
sir.
sir. Yes.
Is it clear? Any doubt you have where to use indoor residual spraying and the ultimate outcome? So the vector indoor residual spraying, you are expecting mainly that reduction in the longevity of the mosquitoes, then vector density, the number of infective bites. And criteria for selecting the insecticide. So efficacy is very important. Then duration of the residual effect. Duration of the residual effect means because you might be knowing that indoor residual spraying they will undertake once in a 3 months or once in a 6 months. So that means you should act minimum the residual activity of the insecticide should be minimum 3 months covering the transmission season or 6 months. Otherwise, it will not be effective. So you have to select based on the these criteria. So efficacy, duration of the residual effect, it should not have any repellent effect because it will not come into the inside the sprayed houses. It will have contact with the insecticide. Then safety to the non-target organism, particularly safety to the human, children, and other domestic animal. Then the vector susceptibility, the insecticide you are selecting, you should be susceptible to that. The target vector should be susceptible to the insecticide. Now, it should be cost productive, cost effectiveness also you have to see that. Then management of the resistance, another important. Suppose the insecticide that you are using, the target vector develops resistance means you should have the alternate mechanism to monitor the resistance. Then other important factors are community acceptability, last bullet, the odor, visibility of the spray droplet, then efficacy against the nuisance pest. These are the important criteria. Otherwise, it will not be successful indoor residual program. What are the limitation of the indoor residual spraying? So, if you use continuously the same insecticide, development of vector resistance, visible deposit, particularly with the DDT, you can see that on the sprayed surfaces, visible deposits on the treated surface. Community may not accept that. People are objection and non-cooperation because you have to, when you go for indoor residual spraying, you have to remove all eatable drinking water, everything you have to keep outside. The occupant should always present there. So because of this reason, particularly the local community, they object the spraying. Washing and plastering of the sprayed walls. This is very important, particularly in the tribal communities, because their huts are made of mud walls. So frequently they plaster the mud walls because cracks will appear in that. Not only that, whenever some festival or ceremony or childbirth or marriage, something happens, immediately they go for plastering of the walls. They will not bother about whether you sprayed the walls or not. Then increased nuisance of household pests like bed bugs. Anybody can explain what is that? Increased nuisance of household pests like bed bugs. Once you apply the indoor residual spraying, the household persons, they complain that frequently now more bedbugs are visible. Anybody can explain? It is not because of the indoor residual spraying that the population of the household, bedbugs increases. Because of the irritation, because of the irritation caused by the insecticide, the bed bugs during the daytime they will not generally the during daytime the bed bugs they will not come outside. Once you spray the household, then during the daytime itself, because of the irritation, they come out of the hideouts. So frequent people used to see many bed bugs after the spray when compared to pre-treatment. Then other operational difficulties such as incomplete coverage, inadequate dosage, spraying after transmission season. It is very common if you happen to see any sprayed villages, so you can see that many places partially only veranda they cover. Sometimes you can see that patchy spray. It will not there will not be any uniform spray. So these are very common sights in the um, malaria endemic areas. So before that, now we have the other component also that indices. So once the spray is applied, what are the indicators you will measure? Indicator for monitoring and evaluation. What is the definition of monitoring? Monitoring is a continuous process designed to verify step by step the progress of the vector control operation. Monitoring measures the quality and progress of activities using the process indicators. What is process indicator? The next slide I explain. Then you should see also the evaluation definition. Evaluation measures the results using the impact and the outcome indicator. The definition of the impact and outcome indicator also the next slide I will give. The impact indicators are the entomological measurement followed. Participants, hello, hello participants. I am audible to you.
Yes, sir,
Yes,
audible,
sir.
sir.
Sometimes you have to respond. Otherwise, I think that I'm monotonously I am talking. So impact indicators are entomological measurement. Outcome indicators are health outcomes. So, indicators for monitoring and evaluation. First, you have seen that process or operational indicators. It is nothing that suppose the in one village they are undertaking indoor residual spraying. So you have to see that percentage of the spray coverage, percentage of the household covered. Suppose you have distributed the insecticide treated nets, then use rate of the LLIN, long lasting nets. That is the process or operational indicator. These indicators determine whether the activities are completed in a timely fashion as defined in the operational plan. It tracks the availability of the resources and materials needed for the program. So first you've seen the process or operational indicator, that is nothing but spray coverage and use rate, that coverage rate of the nets, like that. Coming to the impact or entomological indicator. So you can say that the impact indicator or entomological indicator, it measures the effect of the vector control intervention on the vector population. So example, decreased human vector contact, that is biting rate, reduced vector density, increased mortality of the adult vector. These are the some. It is the impact of the vector control intervention on the vector population. The same thing, ultimately what you are expecting, there should be reduction in the morbidity and mortality. So the outcome or epidemiological indicator, it measures the impact of vector control program on morbidity and mortality due to the disease. So now we are given a table. It gives the everything. What is the the first column? Vector control method, indoor residual spraying. What are the operational indicator? The dosage, correct dosage is applied. Quality, whether it is a uniform spraying or patchy. Coverage, household cover, times of application, persistence, that is residual activity. So these are the operational indicators. What are the entomological measurement? Ultimately, what we were expecting reduction in the longevity or density. So daytime indoor resting density, adult density, then ultimately reduction in the human landing rate, then human blood index, blood feeding index also there should be reduction. Longevity, I told that that is reduction in the virus rate. In a malaria endemic area, you can see that reduction in the sporozoite rate after applying indoor residual spraying. Now it is followed, na? Clear?
Uh,
Hello?
may I, may I sir say
Yes,
something?
yes, definitely. May I know your
Sir,
name, please?
SS Pohan, sir.
Yes, please.
Sir, actually, what is the elaborate of porous rate and sporazite rate?
Sporozoite rate and
Sporozite rate. What is the meaning of, sir?
sporozoite rate, you don't know. Malaria, you know that malaria transmission cycle, you know that.
Yes, sir. No, it's a porous rate. What is the porous rate, sir?
Sporozoite, na?
Yes, sir.
Sporozoite is the infective stage of the malarious parasite in the salivary gland. That
Okay,
is
sir.
so that mosquito, the mosquito that has the sporozoite, if it injects to the human, then he gets infection.
Okay, sir.
Clear?
Thank you, sir. Okay, sir.
Okay. Okay. Because from the human, the mosquito that gametocytic carriers, human, the mosquito takes the blood. Then from the blood it goes that fertilization takes place. Male gamete, female gamete, fertilization takes place. It goes to the gut. Then development of oocyst. Within the oocyst only the sporozoite forms. The sporozoite ultimately moves to the salivary gland. Okay, thank you, thank you. Clear, na?
Sir, clear, sir.
Okay. So we have seen the operational indicator and etymological indicator. Ultimately, what is the epidemiological indicator? Here, same indoor residential spraying. So percentage reduction in malaria incidence, API. The reduction in the infant parasite rate, spraying rate in the malaria endemic area. Percentage reduction in malaria morbidity. Slight positivity rate, API, everything. So this is the outcome indicator or epidemiological indicator. Coming to that, you have space spraying. First, you have seen indoor residual spraying. This is outdoor space spraying. There are two types. You know that one is thermal fogging, another one is ULB cold applicator application. You know that thermal fogging there are two types. You know or not? At least thermal fogging you know that, na? Thermal fogging. Fogging operation they undertake that you know or not?
Yes, sir. We know fogging operation, sir.
Actually, there are two things. One is thermal fogging, another one is next slide. I will show that ULB cold fog. The thermal fogging, what happens? This technique is based on the principle that insecticide is vaporized at a very high temperature inside the machine, which condenses to form a fine cloud of droplets on contact with cooler air when it comes out of the machine. In the program, in thermal fogging, malathium and pyrethrum extract, these two things are useful. Thermal fogging is physiologically more, for community point of view, it is more acceptable because it generates a high visible fog, a cloudy fog, it, visible fog it produces. So what are the equipment? Portable thermal fogger, mist blowers, then vehicle mounted machines are used. The other one, what I told, ULV spray or cold fog. Here, what happens? Minimum volume of the liquid insecticide formulation is used in the program. Technical malathion at the rate of 0.5 liter per hectare is used. The insecticide is broken down into small droplets of, you see the droplet size 40 to 80 micron. They remain suspended in the air for a set time, 15 to 30 minutes only. It is a insecticide droplets are suspended here in the air. Here, thermal fogging, we are mixing the insecticide with the kerosene or diesel. Here, what happened in the cold fog, no diluent is used. The technique is more cost effective than thermal fogging, but it does not generate a visible fog. So you will not get a fog. People think that we are not spraying anything, so only water they are spraying like that. But when compared to thermal fog, cold ULB cold spray is very effective. Equipment used for ULB spray. So portable motorized naphthalene blowers and cold aerosol generators. These are the equipment used. So coming to that, where they use the spray spraying. You might have seen during the outbreak, dengue outbreak, or JE outbreak, they use the thermal fogging. So during the epidemic or outbreak, the vector should be exophily. The vector should stay outside or rest outside considerable time in the outdoor. Isolated resting area from human habitation. Indoor also they undertake this space spraying. Indoor application restricted to conference halls, airport, and other public utility places. Ultimately, the space spraying they cause drastic reduction in the adult density because rapid knockdown. Because the flying, all the flying infected mosquitoes, they will get knocked down. Adult, there's a drastic reduction in adult density. Not only that infected insects, then dispersal of the vector mosquitoes also it prevents. So what are the criteria? For indoor residual spraying, you have to see the residual activity, the insecticide that gives long duration of effect, long residual activity. Here, you have to select a insecticide that gives a rapid knockdown effect because the insecticide you are suspending the insecticide particles in the air. It has the 15 to 30 minutes only it has the efficacy. So the lethal effect you have to see safety, cost effectiveness, then management of resistance. Other factors include acceptability and orders extra. So coming to the indicators, what are the indicators? Here you will measure the area covered, operational monitoring, second column. So first column is spraying, second column we come to that coverage. The area you have covered, area of influences, resources utilized, time of application, cost. Entomological monitoring, reduction in human landing rate, adult mosquito density, virus rate. These are the three important. Insecticide susceptibility actually period to the selection of the insecticide you have to do that. Coming to that, other commonly used vector control option is that larviciding, where to use larviciding. If you have confined and accessible breeding sites within the vector flight range, the criteria for selecting the insecticide, first efficacy, you have to see the cost effectiveness of the insecticide and its application, then environmental safety, because you will be applying in the larval habitat. So effect on the non-target organism that live together with the cohabit with the mosquito larvae. So what are the advantages of larviciding? destruction before being that means before emergence you are killing the target vector. Availability of the many larvicide. You have lot of larvicidal formulation. Here, what is the limitation? Advantages you have seen. What are the disadvantages? It requires frequent application. You see that the timing was the program they are using weekly once they apply. So that is frequent application. So operational cost is more. Effect on the non-target organisms. You have to see that when you are applying in the fresh water, it will not kill mosquito larvae, it will also kill other predatory beneficial organisms. Generally restricted to the confined habitats. So coming to the indices, larviciding. So what you do? Coverage, number of habitat cover, efficacy, persistence, residual activity, then resources utilized, cost. So ultimately, the entomological monitoring, reduction in larval density, then ultimately it will have the impact on adult mosquito density. So coming to the biological control, you know very well, biological control, what we are using in the program. Participant, please. Participants, biological control, what we are using in the program. You
Yeah,
are
this
listening?
is
Sir?
Guppy and Gambuska fish.
Yes, very good, very good. Why? Because I am checking that I am audible to you or not. So you have
Yeah,
to respond immediately. So, any doubt, any question you can ask at the end of this. You can note down. You can at the end of this presentation you can ask. So biological control, where to use? Where it is only the feasible alternate, where it complements. It cannot be a sole method, where it complements the other control measures to manage the insecticide resistance, where chemical methods are prohibited or unaccepted. In such conditions only you can use advantages. We have lot of advantages. Safer to non-target organism and the environment because you are not using any insecticide. Suitable, you can involve the community. Suitable for community use with little or no supervision. You can see that there are two fishes, Gambusia finis, and other one is Poecilia reticulata. So most commonly, the first one, Gambusia finis, is used. It is a exotic fish used in India since 1928. The size is 4 to 7 centimeter. It is a surface breeder, 100 to 300 mosquito larvae per day. That means 24 hours. Poecilia reticulata, other name is guppy. So what is the difference between Gambusia finis and reticulata? This Poecilia reticulata, it tolerates high degree of organic pollution when compared to Gambusia finis. So you can use slightly polluted habitat, you can use Gambusia. More freshwater, clear water means you can use Gambusia affinis. So here the environmental management, why I have taken under this only the source reduction activities come. One of the important component in any vector control program, though initial investment is high, if linked with the developmental activities, it is cost effective in a long run. It will have additional benefit like land reclamation, afforestation, housing, increase in agriculture production, water conservation, extra. So what are the methods available? Again, there are two different types. One is environmental modification, that is a permanent measure. Example, filling. Suppose one unwanted or abandoned well is there, disused well is there. It is better to completely you can fill that. Then filling of abandoned wells, ponds, low-lying plots, closing or screening of or covering of breeding sites. These are all permanent measures called environmental modification. What is the manipulation? So it is a temporary measure or recurrent measure. Suppose the drains, desilting of drains, sanitation, removal of vegetation, flushing the streams, changing of salinity. These are the age-old methods. But recently we are using the desilting and sanitation, the cutting the vegetation along the drains. Changes in the water level, shading of ponds, straightening and steepening of the shorelines. So here source reduction activities, the indices. What are the operational indices? You have the total number of potential breeding sites, number you have reduced, number eliminated. That is very important. Resources utilized, cost involved. So ultimately, after reducing, after eliminating, after undertaking the source reduction, you will expect a reduction in the adult mosquito density. So coming to that other method is now that is long-lasting insecticide net, but I start with the bed net and mosquito net. What is the difference between the ordinary mosquito net, then insecticide treated net, and long-lasting insecticide net? These are the three things. You will start with bed nets. These bed nets or mosquito net, they act as physical barrier. They reduce the man-vector contact. So they reduce the man-vector contact. That means preventing the mosquito from biting. Now, what are the disadvantages with the bed net mosquitoes? The hungry mosquitoes, they remain. Hungry mosquitoes, they remain to feed. They will wait for feeding because since you are sleeping inside the net, the mosquito, they are hungry, they just wait to feed. Waiting, they will be waiting for feeding. Then unprotected person sleeping nearby the mosquito net will become the target. Suppose some are protected and the other people sleeping without bed net means they will become the target. Mosquitoes feed. Sometimes while sleeping, your head, hand, leg, it will come out of the net. Feed on the body parts, touching the nets while sleeping. To overcome that, what we have done? We have used insecticide treated nets. So the insecticide treated net, they irritate or kill. ITN means insecticide treated net. They irritate or kill mosquitoes on contact, preventing them from finding the opening, make the mosquitoes that survive the contact with the insecticide so disturbed. They are so disturbed that they are unlikely to attack again. It offers protection to the people who sleep outside a net but near someone with a treated net, protecting the vulnerable group, particularly the children and the pregnant women. They not only kill that they prevent the mosquitoes from feeding, killing other biting insects, bed bugs, head lice, chicken ticks, house flies, so that the community acceptance is very high. So what are the problems with the insecticide treated nets? Coverage and distribution is one, acceptability by the community, compliance to appropriate use, access to the nets, and here what is more important is the retreatment. So every 6 months or every 1 year you have to go for treating the mosquito net depending upon the residual activity of the insecticide. So to overcome that, now the program they have introduced long-lasting insecticide treated nets, that is LLIN. So long-lasting insecticide net is a net treated at a factory level, manufacturing factory level itself. They are treated a net treated at factory level with the insecticide either incorporated into or coated around the fibers resisting to multiple wash because these nets that again I will come resisting to multiple washes and whose biological activity lasts as long as the net itself. The duration of the net is Life of the net is 3 to 4 years for polyester net, 4 to 5 years for polyethylene nets. So insecticide effect last, you see, as long as 4 to 5 years the nets are intact means the insecticide effect also lasts as long as the lifespan of the net. That is one important point with the LLAN. A retreatment is not required. They are vast resistance. You can go for washing 20 times during the lifespan, 20 to 25 times. So already WHO they have given, there are many nets are available. The WHO Hoopers they have given full recommendation. One example is a permanent. The permanent, the impregnated insecticide is covered by a resin coat. So the insecticide is covered by a resin coat around the fiber in the permanent. Whereas in case of Volicide, the insecticide permethrin, it is incorporated into the fibers. So you have the net fiber, the insecticide is incorporated into the fibers during the manufacturing program. These are two examples. So now how it becomes the vector control options, insecticide impregnated bed nets or LLIN. So mosquito nets become vector control tool when they are treated with the insecticide. So LLIN is treated with the insecticide when most of the people in the community use them, producing a mass killing effect. Then it comes in the vector control option. So coming to that impregnated mosquito net, what are the operational or process indicator? The dosages that you have treated the net, whether the dosage is applied correctly or not, coverage of percentage of the household covered with the net, percentage of the population covered with the net, then use rate. Suppose 100 nets you have distributed, the use rate of the net, persistence, residual activity. Already that we use, I mentioned that it is effective 4 to 5 years as long as the net is intact. So persistence, that is residual activity, resources utilized, cost. So what are the entomological monitoring here? So you have to see because the net it prevents it reduces the man vector contact. So you have to see the biting pattern after using the LLAN, activity in relation to sleeping habit. That is very important. Suppose prior to the sleeping also, you see people go to the bed after 8 or 9 or 10 o'clock. Prior to that also mosquito starts biting them. So activity in relation to the sleeping after introducing the LLN, you have to see the activity in relation to sleeping habit, use of other repellents, then reduction in the man landing rate, human blood index from resting population, sporozoid rate, insecticide susceptibility rate, adult mosquito density. So you have seen the entomological or impact indicator. Now coming to that outcome or epidemiological indicator. So, impregnated mosquito net, number of people in the area of bed net use, target population you have covered, number of people living in the houses in which the nets are used, number of people using that is use rate. These are the things you do. Then outcome, that is epidemiological indicator on the human population. So percentage reduction in malaria incidence, that is fever incident, severe malaria, reduction in parasitemia in the target areas or group. Percentage reduction in the malaria mortality and also all cause mortality. Then larvicide, what is that outcome of the epidemiological indicator? So, after undertaking larvicidal measures, ultimately you are seeing that whether the area is free from malaria, or any other vector-borne disease incidents. Okay, thank you.